Okay. Hello, everyone. So today we're going to go ahead and learn 2.4 Fundamental Theorem of Algebra. This was the lesson that was presented on Thursday. So let's go ahead and begin. So go ahead and pause the video and try these examples. Okay. Alrighty. So hopefully you were able to try this, and you can go ahead and see that you should be aware that when x plus z is raised to an even exponent, it goes ahead and touches. When x plus c is raised to an odd exponent, it crosses, right? And we're talking about touches or crosses the x-axis. Alrighty, so let's go ahead and begin. So the first zero I can see is that at x equals -2. So at x equals -2, we can see that we have this right here, and it went ahead and touched the x-axis and bounced back. So we're going to go ahead and see that this at x equals 2, this in reality should be moving this entire term to the other side. This should be x plus 2 should be raised to an even exponent. So we can go ahead and say that, let's go ahead and call it 2. So this multiplicity should be an even number, so let's call it 2. But ideally, any even should work. Already at x equals 0, we can see that the same thing occurred, and it went ahead and touched and bounced back the x-axis. So we can see that this should be at x equals 0. When we move to the left, x minus 0 doesn't make sense, so just x is on its own, so x should have multiplicity, and then still even, right? This was even, because it touched the x-axis and bounced back. Ooh, look at this, x equals 2. We can go ahead and see that it went ahead and touched the x-axis and crossed. So not only did it touch, but it went ahead and crossed. And we can see that this right here is going to be an odd. And if you think about it like so, it pretty much behaves like a cubic function at this point. So at x equals 2, we have x equals 2. If I move it to the left by subtracting, x minus 2 should be an odd. And I could just say multiplicity should be a 3 or any odd value, but exponent. Last but not least, we got x equals 0, and we can see that it's at this point, it touched and bounced back. It looks like a parabola, if you will. So x minus 4 is probably an even, so multiplicity is even. Okay, alrighty. What I'm going to go ahead and challenge you with is I want you to go ahead and create the polynomial of this. One of the possibilities. Well, this really isn't that bad. What I need to know is how does this behave? Well, the left is going to the negative and the right hand side is going up. So overall, it should be an odd degree. So you're pretty much going to use the zeros, and as we mentioned, we're going to move to the left, so to get them into factored form. So there's an x plus 2, this is an x, there's an x minus 2, and there's an x minus 4. All I did was instead of solving for 0, I made the right hand side equal 0 by either subtracting or adding. So I'm going to go ahead and see that I have this term right here, x plus 2, and it bounced, so it touched the x-axis, so I'm going to go ahead and make that positive 2. The next one says x, and that is also even, so I'm going to leave it squared. The next one says x minus 2, and that one crossed, so I'm going to go ahead and say that's an odd, so a 3 works, or a degree of 1 also works. And we have the last one, x minus 4, also touched, so it's like this. So this is a possibility, and we can check the degrees. We have 2, 4, 6, and then plus 3, that is 9. So it's a degree of 9. 9 and a degree of 9 behaves like a cubic. So this is a pretty good estimate, right? Alrighty. So this was from the video from last week. I don't know how I forgot to upload it. But as you guys know, this is pretty tough. So tough on both of us. So I tend to forget. Alright, friendly reminder, tutorings are from 4:30 to 5 on Tuesdays. Okay. All right, so we're gonna go ahead and determine the fundamental theorem of algebra, whatever that means, and find the real roots and complex roots. So fun stuff. Okay. So before we begin, I want to go ahead and show you that pretty much an algebra 2 review, if you were given this value k, if you were asked to find this value k, can you find it if we are given that the factor that this has is x plus 2? So go ahead and give that a try. Given what you know, if this is a factor, means if I was to do synthetic division, my remainder is 0. Okay, so pretty much what I'm saying is that if you were to solve for x plus 2 equals 0, I would get that x equals negative 2. Okay, now the factor means that there is a 0 remainder. So if I was to substitute negative 2 into this function that they gave me, my value should equal 0 if I substitute negative 2 into every x value, if I evaluate for negative 2. Okay, so let's go ahead and do that. Let's go do this nice algebra. Negative 2 cubed, that's negative 2 times negative 2 times negative 2. That is negative 8. And then plus 3 times a positive 4, that is a 12. Plus, and then this negative 2 times k, that's a minus 2k. And a positive 6. So we can go ahead and see that this 12 and this 6 add together, and that gives me a positive 18. So I got negative 8 plus 18 minus 2k. And I can see that this is a 10 minus 2k. And I can go ahead and solve for it. Let me go ahead and give myself more space. And if I move the 2k to the right, because all of this equals 0. So if I move the 2k to the left, I get that 2k equals 10. And I can solve for k by dividing by 2. So k is equal to 5. So if they're asking you to find this value right here, I want you to know that if it says that it's a factor, you could use synthetic division, or you can use the same method to find out what that it means. Okay, so if you're, just kidding. No, that's fine. So, alrighty, so go ahead and do this example. So go ahead and pause the video and give this one a try. Same exact thing. We are given that x minus 1 is a factor, so let x equals 1. And go ahead and find the value k. So pause the video and give this a try. Okay, so we have 1 cubed plus 5, 1 squared plus k times 1 minus 7. And since it's a factor, the remainder must be 0, meaning this function must be 0 when x equals 1. All right, let's give this a try. So I got 1 plus 5 plus k minus 7 equals 0. And I'm going to go ahead and combine like terms. 6 minus 7 plus k equals 0. So therefore, I can see that negative 1 plus k equals 0. So k equals a 1. Okay. All righty. So not that bad, right? So the fundamental theorem of algebra. So go ahead and write this down on your notes. So pause the video, write this down. And pretty much the fundamental theorem of algebra means, well, it's telling us that the degree that we have means how many zeros we have, whether they're real zeros or non-real zeros, meaning imaginaries and complex numbers. So what I want you to know is that when x is squared, the degree is 2, right? The largest exponent, whatever polynomial you have, tells you the amount of zeros. So if the degree is 2, then it has 2 zeros. If the degree is 17, well, then it has 17 zeros. Same thing goes if x equals 105. Well, there must be 105 zeros, whether they're real numbers or imaginary or complex. Okay, so what are complex numbers? Well, a complex number includes a real number. Let's call that a. And an imaginary, let's call that the I, the bi. Okay, it appears that I forgot this, that right here, this should be an I. The square root of negative 1 equals I. And a fun fact, if you square the I, you get negative 1. And that's the same way you can find I cubed if you multiply by a square root of negative 1. Okay. Alrighty. Okay, the conjugate pair theorem. Well, this is pretty much what I want you to know. The moment you see a number that has an I, automatically you have its conjugate pair, meaning that you have the negative version of that number. So let's say, hey, this polynomial has a 0 of 2i. Well, guess what? This also has negative 2i by the conjugate pair theorem. If you see that has an imaginary, it automatically has a second, meaning the opposite sign. Something I want you to know is that the a does not change sign. Notice how it stays positive, stays positive. So the b, on the other hand, did change from positive to negative or negative to positive. Alrighty, let's go ahead and assume we have a polynomial, right? Let's go ahead and do this example. Let's say we have a polynomial and it has a degree of 2, and this is 1, 0. X equals 3 plus I. So by definition, I want you to know that it also has another 0. X equals, what do you think that is? 3 minus I. It's probably the other 0. Actually, it is. Not probably, but it is. Okay. Alrighty, let's go ahead and continue. I got a meme for you. Pretty much summarizing what I just said. That a degree equals a quantity of zeros, whether there are negatives, whether they are positives, or whether they are imaginaries. So real and non-real. Okay, so go ahead and do this this example. So how many possible zeros are there? So from here, I want you to use your P and your Q's. Remember, your P comes from this and your Q, so a little bit of review. So this is your P, this is your Q. And what we want to do is factor them out, find the factors, and find the possible zeros, P over Q. So the factors of 1 is 1, and the factors of 4 is 1 and 4, and 2 times 2, so just 2. Okay, so let's go ahead and do our P's over Q's. So find all our possibilities. So it's going to be plus minus, okay? And all our numerators divided by all our denominators. So all our P's divided by all our Q's. So I'm going to get the positive version of 1 over 1, 1 over 2, and 1 over 4, the positive and negative version. So I have 3 positive and 3 negative. So total 6 possibilities. Well, what I want you to know now is that you can go ahead and find out what the real zeros are. And this goes back to what you already knew on your synthetic division. You go ahead and pick one. So x equals, let's say, negative 1/2. You go ahead and use that for your synthetic division. So go ahead and do this. This x equals negative 1/2. This is 4, right? We get the coefficients just like we learned the other day. Okay. And we go ahead and simplify the best that we can by bringing the first term down. If you need a reminder of this, I made a video about it, about how to do synthetic division. And I multiply 4 times negative 1/2, that is negative 2. And I can go ahead and see that this is going to give me negative 6, right? If I add them. And then 6 times the 1/2 here, negative 1/2 will give me a positive 3. And if I add these, this gives me a 2. And if I multiply 2 times negative 1/2, gives me a negative 1. And I get a remainder of 0. So this is indeed one of the real zeros. So is this the only way to do it? Of course not. You can actually get x equals negative 1/2 and substitute it into these x's. And if it gives a 0, it is a factor. So it is a real 0. And think about it like you put in an x and your height will be at y equals 0. So it will touch the x-axis. Okay. The reason I prefer to do it using synthetic is because of the following reason. You're able to go ahead and do synthetic division from here as well. So we're able to see that this is 4 minus 6 minus 2. This is the same thing as saying 4x squared minus 6x plus 2. So keep in mind, you can probably do also like quadratic formula, factoring, and synthetic division one more time. So it's completely up to you on what you prefer to do. Okay. So I'll give that as an exercise for you guys to find the remaining, how many zeros? Well, let's look at the degree. There should be 2 more zeros here as well. Okay, so pretty much long division, synthetic division will help you out in finding the real zeros. So hopefully you enjoy that meme. Okay, is that the only way to find the real zeros? Well, actually, no. You can actually factor, set it equal to 0, and you can find the zero. So I'm going to go ahead and explain how to do factoring by grouping. So you look at these terms and these terms separately. So you go ahead and look at this and you find out, what do these terms have in common? So I got x cubed minus 5x squared. Write it out if it makes more sense to you. So hopefully you're able to see that these terms right here have 2 x's in common. So I'm going to go ahead and factor that out, and I'm left with just an x minus a 5 for the first part. Let's go ahead and look at the second part. I have a 16x minus 80. Well, they're even, so 2 is a factor. What else will be a factor? Hopefully you're able to see that 16 is also a factor. And if I factor 16 out of 16x, I'm left with x. And if I factor 16 from 80, I'm left with 5. So I'm left with this so far. Okay. Now, what I want you to know is that if I was to factor all of this again, what do these terms have in common? Hopefully you're able to see that this term and this term. So I can factor that out. And I'm left with, well, if I factor it out from here, left with x squared. Yeah. Oops. I closed the parentheses. Why did I do that? X squared plus the whatever's left, which is 16. So I have that this right here, f of x equals x minus 5, x squared minus 16, is the same factor as that. Is the same function as this one right here. Okay. Alrighty. So how do we make an equation give us the zeros? Well, if you are given a 0, let's say a 0 at x equals 5 and a 0 at x equals 2, you can actually modify that the same way we did with the graph and create a polynomial with whatever degree they want us to have. So this one says it has to have a degree of 3. So there should be 3 zeros. So all you have to do is get whatever they gave you, x equals 5, you move it to the left. So x minus 5 equals 0. That is one factor. So this should be x minus 5. X plus 3 becomes x minus 3 for the same reason we move it to the left, but it has a multiplicity of 2, so this has to be x squared. So my function, that the possibility for this is x minus 5 x minus 3 squared. So pretty much this right here will go ahead and help us out. So this will be a possibility of an equation that has these zeros. Alrighty, the next one. How about a degree of 5? So go ahead and pause the video and give this a try. So x equals 5, x equals negative 3, and x equals 2 with a multiplicity of 3. Remember, this only affects these. So go ahead and give that a try. Pause the video, give it a try. Okay, so I have x minus 1, x minus 5, right? Because if I move it to the left, I subtract that minus 5, and x plus 3. Then x minus 2, and it has a multiplicity of 3, so it has an exponent of 3, only this one right here. So my possible function should be x minus 5, x plus 3, and x minus 2 cubed. Okay, so that's a possible function that could represent this. Okay. Ooh, imaginaries. Go ahead and give this one a try. So degree of 3. So it's going to be x, right? If I move this to the left, it's x minus 3. And then x 2i. Well, let's think about that. If it's 2i, automatic, I should be thinking that, hey, this gives me x equals negative 2i, right? And those are the 3 zeros. Degree of 3 should have 3 zeros. So I move it to the left, I get x minus 2i, and I get this one, x plus 2i is my function. Okay. ahead and try this one. This has an imaginary, so automatically have its conjugate pair. So keep in mind the 1 stays positive, the 3i, and the hand takes negative I. Okay, and then you do the same thing. You move everything to the left. So it was originally 1 plus 3i. So this tends to confuse students a little bit. So if you move it by individual parts, so it's x minus 1, and the 3i, you move it to the other side. This is one factor, and you do this to the same thing. It's going to be x minus 1, and the 3i that was negative, you move it over, so that becomes plus 3i. And they're not like terms because one is imaginary and one is not. Okay, so we have all of that so far. Okay. Alrighty, so for the exit ticket, guys, I want you to go ahead and find out the value k, okay, and make a polynomial with a degree of 5 and these following given zeros, okay? So go ahead and give that a try, and I'll be waiting for your exit ticket. Okay, that's all that I have for us today. So go ahead and make sure you answer the exit ticket and do the homework, which is due on Tuesday. As always, guys, it was a pleasure. Thank you. Bye.